What we're doing today is just an extension of what we did on Friday. So Friday we graphed the quadratic parent function.
Oh,
And
it's
today we are going to still graph quadratic functions, but we're going to graph them in order to solve quadratic equations and inequalities through graphs. So for number 1, the instructions say solve each equation using transformation. So when we graph the left side, because of the square, it's going to be a parabola. So because of the square, it's going to be a parabola. And when we graph the right side of the equal sign, it's going to be a horizontal line. And we're going to use our transformation to solve it. So looking at the left side, we have x minus 1 in parentheses squared. What does the minus 1 inside the parentheses make the parent function do? Right 1. So from the origin, we need to move it to the right 1. And use your pattern. If I go over 1, what is 1 squared? 1. So over 1, up 1.
on both sides. Yeah.
On both sides. Over 1, up 1.
Over 2.
If I go over 2, what is 2 squared?
4.
4. So over 2, up 4. And same thing on the other side. Over 2, up 4. If I go over 3, what is 3 squared?
9.
9. Do I have enough room to go over 3 and up 9?
No.
No. So those are the only points that will fit. Go ahead and connect them with a smooth curve. Make sure it's rounded at the bottom.
Yeah, it's gonna be. My solutions are 8, right?
The solutions, yes, we're solving for x today.
8 equals 1. Oh, I'm tripping.
Zero. So there's the left side. Now when you graph the right side, it's going to be a horizontal line. So we need to graph a horizontal line that goes through 4.
Negative 1, 4, and
And we are looking for the points where they intersect. So the parabola touches that horizontal line at -1 and +3. So when we write our solution, we are solving these equations for what variable? X. So you need to write your answer as the x coordinate of the point of intersection. So looking at this left point of intersection, what's the x value there?
-1.
So -1 is going to be our first answer. And looking at the second point of intersection right here, what is the x value here? 3. I'll just put a comma and then a 3. So -1 and 3 are the two answers. You can don't write them as an ordered pair because we just want the x value only. So if you write it as an ordered pair, it looks like you're putting x and y. Or it looks like interval notation, which would mean -1, 2, 3. Or you can write them separately. You can put x equals -1, x equals 3. So you can write them separately or put it together in 1. Okay, next one. Number 2.
You gotta go left 2 and down.
What is the negative up front going to make it do? Go down. What is the +2 what does the +2 on the inside make it do?
Left 2.
Left 2. What about the -2 at the back?
Down 2.
Down 2. So from the origin, we need to go left 2, down 2. And that negative out front, let's be more specific. That negative doesn't necessarily make it go down. What's a better word for that?
Reflect.
Makes it reflect. So instead of pointing upward, it needs to point downward. Now instead of going right 1 and up 1, the negative means we have to go down 1. So from the vertex, we need to go right 1 and down 1. On both sides, right 1 and down 1. So if the a value is negative, it has to point down, not up. If I go over 2, what is 2 squared? 4. So you go over 2 and down 4. And do we have enough room to go over 3 and down 9? No. So connect those points.
-4 and -2.
horizontal line?
-6.
Through -6. Now, if it does not meet at a nice intersection point, that means you did not graph something correctly. So go back and check your graph. Now we're looking to see where does that parabola hit our horizontal line. So they intersect right here and right here. So how many answers did I have? 2. And when you write your answer, we're solving this equation for x. So you need to write the x value of each of these points. So for the left point, what's the x value right here? -4. What's the x value right here? 0. So x equals -4 and 0. You can put it together like that, or write them separately.
0.
Huh?
Why 0? It is the x value.
If you look right here, what is the x value for this point? The x value is 0. It's the y value that's negative.
Oh, shit.
Yes. It doesn't matter which number comes first, but typically we list them least to greatest. So you do have to have both answers. Technically, it doesn't matter which one you put first, but you have to have -4 as one answer, 0 as the other. Okay, I want you to graph and solve number 3. Okay, number 3. What does the 1/2 out front make the parent function do? It's a shrink by a factor of 1/2. So it's only going to go up halfway. And what does the +3 inside the parentheses make it do? Left 3. So from the origin, you should have moved left 3. We normally go over 1 and up how much? 1, but you only go up half of that, so half of 1 would be a half. So go over 1, up halfway. So go up to 0.5. If I go over 2, what is 2 squared? 4, what's half of 4? 2. So over 2 and up 2. If I go over 3, what is 3 squared? 9, what's half of 9? 4.5. So over 3, up 4.5. Over 3, up 4.5. If I go over 4, what is 4 squared? 16, and then half of 16 would be 8. So over 4 and up 8. Over 4 and up 8. Connect those points.
I didn't know you could go over 4. I thought I had to.
Normally we don't go over 4 because 16 will fit on the grid. But here, since we're shrinking it by a factor of 1/2, we will go up to 4. Because half of 16 will fit on the grid. And where do we draw the horizontal line? There's 2. Locate the points of intersection. So they intersect right here and right here. And what are those x values? -5 and -1. So make sure you have both of those answers, -5 and -1. Okay, number 4. Number 4, it says the table below shows ordered pairs that satisfy the quadratic function f. Question A. Name one solution to the equation f of x equals 0. So they're telling us y is equal to 0. So if they are giving you y, you have to find x. So when y is 0, look through the y column. Where do you see 0? Right here on this row. And when f of x is equal to 0, what is x equal? -2. They gave us y. Our answer needs to be x. So if y is 0, the x value is -2. Question B, it says in what interval is the other solution found? So they're telling us that was the first solution when y is equal to 0. But they're telling us that there's going to be a second solution in that table. So where is the second 0 in the y column? It's not visible. It's actually disguised. Think about a number line.
So we still don't get the calculator in this section?
We are not using a calculator today. This will be on the no calculator section of our next section. So think about the number line. We normally have 0 in the middle, and what numbers are on the right side of 0? Positive numbers. And what numbers are on the left side of 0? Negative. So I know that 0 is going to fall somewhere between a negative number and a positive number. So what we need to do is we need to look through the y column and find where we have a positive and negative number back to back. So if you look at 26, 26 is positive, 10 is positive, 0 is neutral, -4,
-2C.
-2, 6 is positive, 20 is positive. So we're looking for a pair back to back where we have a negative followed by a positive. And where did you say that was? -2 to 6. So do you agree that on a number line, I'm going to count by 2. So we came up with -2 and 6. Do you agree that 0 is going to be between those two numbers? Definitely. So 0 is going to be somewhere between -2 and 6. So they gave us the y values. Our answer needs to be in terms of x again. So here the x value is going to be an interval. And what are the boundaries for our interval? 0 to 1. So we're going to write that as an and inequality. So the x interval would be from 0 to 1. That's the answer. That was the answer. We found where the missing 0 was, and that was for x values from 0 to 1. So it's going to fall somewhere between 0 and 1.
That doesn't seem very specific.
It's not very specific. It's probably going to be closer to the 0 than to the 1, but we don't know exactly because we don't have an equation or even a graph to look at. So we're just estimating.
So you get a decimal?
It could be. Most likely it would be. Okay, on the back. Now we are going to solve these inequalities. It's going to be similar at first to what we were doing on problems 1, 2, and 3. We're still going to graph the left side, and it's going to be a parabola because of the square. And when we graph the right side, it's going to be a horizontal line. So when we graph the left side, what's the -3 inside the parentheses make our graph do? Right 3. What does the -1 at the back make the graph do? Down 1. So from the origin, we need to go right 3 and down 1. If I go over 1, what is 1 squared? 1, so over 1 and up 1. If I go over 2, what is 2 squared? 4, so over 2 and up 4.
You can't go to 2.
If I go over 3, what is 3 squared? 9. Do we have enough room to go over 3 and up 9?
Yes.
Yes, we do. And that's because this translated 1 unit down. Connect those points. And where do we draw the horizontal line?
3.
Through 3. Now again, if it does not intersect at nice points, you graphed something wrong. So go back and check your graph. And we are still looking to see where they intersect. They intersect right here at 1 and 5. So 1 and 5 will be included as part of our answer. Now when we write our answer, well, first of all, let's go ahead and do the shaded. Then we'll talk about how to write our answer. So this one is not an equal sign. We have a less than or equal to. If you have a less than symbol, do you shade above the red line or below the red line? Below. So if it's a less than, you shade below. Now, when you write your answer, it's going to be a compound inequality. It could be an and inequality, or it could be an or inequality. So I want you to write this down somewhere in the margin. Now, if you shaded the arm, then your answer would be an or inequality. And what your answer would look like, you would have x is less than a number, or x is greater than a number. Your answer would look something similar to that. This is just the general format. We'll talk more specifics and see these in examples here in a few minutes. And the other type, if you shaded the vertex, your inequality would be an and inequality. And the way that your and inequality would be written, you would have x in the middle, less than on the left, less than on the right. You'll have your lower boundary and your upper boundary. Okay, so when you are trying to decide which part did you shade, when I'm talking about the arm, I'm talking about these pieces that have the arrows on them. So this is the arm, and this is the arm. Now the vertex, well, this part that we shaded in purple, it definitely has the vertex shaded. So this is going to be an and inequality because we shaded the vertex. And our answer will be in this format. We'll have x in the middle, a less than on the left, and a less than on the right. Now, yes, this is an and inequality. Less than on the left, less than on the right. It's always less than, never anything different. Unless it's equal to. If it's equal to in the problem, these need to be equal to in the answer. Now look at your points of intersection. For the left point, what is the x value for the left point of intersection? 1. So the lower boundary is a 1. Looking at the right point of intersection, what is the x value there? 5. So 5 would be the upper boundary. So if you shaded the vertex, it's going to be an and inequality. And use your two endpoints for the values for the lower and upper boundaries. Next one.
Hold on.
Yes.
Now, where you get them from?
You get them from the points of intersection. If you look at this point of intersection, the x value is 1.
Oh,
If
okay.
you look at this point of intersection, the x value is 5.
Alright.
And then you just drop them down. There's the 1, there's the 5. Next one, number 6. What does the minus 2 inside the parentheses make it do? Right, 2. What does the minus 3 at the back make it do? Go 3. Down 3. So from the origin, we need to move it. Right 2 and down 3. Go over 1. What is 1 squared? 1. So from the origin, we need to move over 1 and up 1 on both sides. When I move over 2, what is 2 squared? 4. So over 2 and up 4. And if I move over 3, what is 3 squared? 9. So over 3 and up 9.
That
That scared
scared me.
me. Won't be right. And where do we draw the horizontal line? Through 6. Now, find your points of intersection. So -1 will be part of the answer, and 5 will be part of the answer. Now we have to figure out what part do we shade. So if it's a greater than or equal to, if it's greater than, do we shade above or below? Above. So if I shade above, I need to shade this, and I need to shade that.
But you always tell us
When you shade, you look at your symbol. If it's a greater than, you shade above. If it's a less than, you shade below. So you shade all of the parabolas above that red line. So everything above the horizontal line. So now I have to decide, is my answer going to be an and or an or? So I have to look to see, did I shade the arm or did I shade the vertex? The arm. So if you shaded the arms, it's going to be an or inequality. Then we have to come up with our 2 inequalities. Starting with the left arm. This left arm is going up, but what other direction is it also going? It's going up into the left. So our symbol needs to point to the left. So we need to have a left there. So the left arm keeps going to the left. So we need to have a left hand symbol. It needs to point to the left. Now, it's equal to in the problem, so it's going to be equal to in our answer. And looking at the left arm, what is the point of intersection right here? What's the x value? -1. So we're finished with the left arm. Now for the right arm, it needs to start with an x. The right arm, it keeps going up, but it also keeps going to the right. So if it keeps going to the right, my symbol needs to point to the right. So I need a greater than. It's equal to, yeah, it's equal to in the problem, so it's equal to in the answer. And looking at the right arm, the point of intersection is at 5. So the first symbol is a less than, second one is a greater than. So the left arm points to the left, right arm points to the right. We'll do another one together, then 8 and 9 you're going to try on your own. Number 7, what does the negative up front make it do? Reflect over the x-axis, and the 3 will make it stretch vertically by a factor of 3. What does the +1 inside the parentheses make it do? Left 1. -4 at the back. What about the -4 at the back?
Down 4.
Down 4. So from the origin, we need to move it left 1 and down 4. Now we have that -3 out front. So because of the negative, instead of going up, we'll have to go which way? Down, but we're not going to go down 1. We need to go down how many? 3. So from that vertex, we need to go over 1 and down 3. And those are the only points that will fit. And where do we draw the horizontal line? Through -7. And find where they intersect, so -2 will be in the answer, and 0 will also be in the answer. Now I have to figure out, am I shading the arms or the vertex? So look at our symbol. If it's a left hand, do we shade above or below? Below. So when we shaded below, did we shade the arms or the vertex? So if we shaded the arms, is this an and or an or? Or. So make sure you have the word or in the middle. And starting with the left arm, your inequality has to start with x. And the left arm keeps going which way? To the left. So your symbol needs to point to the left. Is it equal to? No, it's not equal to in the problem, so it's not equal to in the answer. And looking at the left arm, where does it intersect that horizontal line? -2. So the first one is the left hand, because the left arm keeps going to the left. And for the right arm, it needs to start with an X, and the right arm keeps going to the right. So your symbol needs to point to the right. Is that an equal to? No, it's not equal to in the problem, so it's not equal to in the answer. And for the right arm, what is the X value for the point of intersection? 0. So if you shade the arms, it's going to be an or. One thing I do want to point out to you, this is the only way I can remember it. Arm, or, they both have the letter R. That's how I remember it. So if the arms is the or, vertex would be and. Okay, on question number 8, I want you to graph it and solve it. We're working on number 8. Mr. Boyd.
Couldn't really ask questions.
8, what does the plus 4 inside the parentheses make our parent function do? Left 4, and the plus 4 at the back. Up 4, so from the origin we need to move left 4 and up 4. And we need to go over 1, up 1, over 2, up 4. Connect those points with a smooth curve. And where does the horizontal line go? There's 5. Woo! There's 5. I was looking at 6. I thought I cracked something off. We're good though.
You are?
We are. Because it intersected right here at -5 and -3. So you should have had -5 and -3 in your answer. Now which part do we shade? If it's a greater than, do you shade above or below? Above. So shade above, shade above. So did I say the arms or the vertex? Arms. So is the answer an and or an or? Or. So put or in the middle. Writing the inequality for the left arm, put your X first, and the left arm keeps going which way? To the left is equal to in the problem, equal to in the answer. And what's the point of intersection for the left arm? -5. And for the right arm, make sure this one also starts with X. And for the right arm keeps going which way? To the right, so we need a greater than symbol. And it's equal to in the problem, so it's equal to in the answer. And the right arm, what is the X value for the point of intersection? -3. Questions on number 8. A lot of you have already done number 9, so let's take a look at number 9. Number 9, what does the -3 inside the parentheses make it do? Right 3. What about the plus 1 at the back? Up 1. So from the origin, you should have gone right 3 and up 1. Then over 1, up 1. Over 2, up 4. And those are the only ones that will fit. And where did you draw the horizontal line? 2. Find where they intersect. They intersect at 2 and 4. So you should have had 2 and 4 in your answer. And for the shading, if it's a less than, should you shade above or below? Below. So if I shade below, did I shade the arms or the vertex? Vertex, so is this an and or an or? And. So put X in the middle, less than on the left, less than on the right. What else is that missing? Equal to is equal to in the problem, so it's equal to in the answer. And what are the 2 points of intersection? 2 and 4. Now, so the smaller one is on the left, the larger one is on the right. So 2 to 4 inclusive.